These are a few problems from page 2 of the 17.1b assignment, right triangle trigonometry. These were not actually covered in the 17.1b notes. They're a carryover from the 17.1a notes. But solve the triangle means we need to find the measurement of every side and every angle. I usually write this out first so that I will have a place to put everything down that I know. And then they didn't draw me a triangle, so I came over here and I drew a triangle. I'm going to pause the video just for a second and fill in the things I already know. Notice that even though the list didn't tell me angle C is 90 degrees, the directions told me angle C is a right angle. So if I come and I want to put those onto my picture, I've drawn this picture and I always start the picture the same way. Angle C at the right angle, unless somebody told you otherwise. In this case, they specifically told you that. I need to put on side B, so I look at angle B, and I know that side B is opposite from that, 3.6. You're drawing the picture yourself, but you still know lowercase b opposite from capital B, lowercase a opposite from capital A, lowercase c opposite from capital C, and C is going to be my hypotenuse, which is C is going to be 13. I have two angles to find and I have two sides to find. When I see a right triangle with two known sides, I usually just go ahead and start with Pythagorean theorem. So let's say a squared plus b squared equals c squared. And I don't know my a, but I do know that b is 3.6. And c, 13. Okay, I happen to know 13 squared is 169. I do not know 3.6 in my head. I don't know 3.6 squared in my head, but I'll use a calculator and I'll figure out that 3.6 squared, 12.96. Okay, I need the a squared alone. So I'm going to subtract 12.96, subtract 12.96, which gives me 156.04. So now I have a squared equals 156.04. I would hate to have to split that out up and find an exact answer like we were doing on the first section here. But this section says nearest tenth, so I'm square rooting. Yes, I want to see that square root step. A squared equals, calculator is telling me 12.49 something. I'm looking, I keep forgetting to get rid of that a squared. I'm looking for nearest tenth, which means I want one place past the decimal. But in this case, if the 4 is followed by 5 or anything larger than 5, 4 is pushing up to a 5. So I have side A, 12.5. There's the missing side. I need to go back and find my angles. I don't know any angles yet. So I'm going to have to use sine or cosine or tangent. So I'm going to look at my triangle and I'm going to analyze. If I want to find angle A first, then I'm going to work with angle A and I'm going to say, I don't know this one that's opposite A. That would be lowercase a. But I do know my hypotenuse. And side B is touching, but not a hypotenuse. That means this is my adjacent side. My 3.6 is adjacent to A, and my C is, of course, my hypotenuse, which uses adjacent and hypotenuse. Looks like I'm going to have to use cosine. So I'm going to say cosine theta. And remember, theta is a circle with a horizontal line through it. I do not want to be seeing theta looking like that. That means null symbol, That means no solution. That is definitely not a theta. Some of you might argue that that's an OK zero, but it is definitely not a theta. There are a few of you who like to do it like a cursive O. That's okay, as long as that line comes about halfway down. It's not going to work very well if it's up top, because it's going to look like an O. So cosine theta equals the adjacent side over the hypotenuse. So I'm saying cosine theta equals adjacent side 3.6 over the hypotenuse, which is 13. And in this case, the angle we're using is we're working from A. So let's write an A in that spot. Okay. And you can get the A out of the cosine. You can't divide out the word cosine. Cosine's all tied up with that A. The only way to get the A by itself is to use the inverse. A equals the inverse, little negative 1 shows inverse, of 3.6 over 13. Notice that I did not take my calculator, divide 3.6 by 13, and write down a rounded off answer. That is not what we're doing here. We're keeping it as accurate as we possibly can. We're going to put it into our calculator that way. Usually, inverse cosine for most calculators means use your second or your shift button, then your cosine. Just like when we were doing 17.1a, you need to make sure that you know, does your calculator want the number before the cosine button, after the cosine button? Most calculators, it's typed in this order, but we get the inverse cosine by doing second or shift. Okay, my calculator tells me that the inverse cosine of 3.6 over 13 is 73.92. I'm looking for nearest tenth, which means I want one place past the decimal. I want that 9. The number that follows it is 2. Anything that's smaller than 5 cannot push it up. Just 73.9. So I'm coming over here to A. I'm writing down 73.9 and make sure I put some degrees on that. I need B. And I usually try to say use only the original numbers to figure things out so that one error doesn't compound another error, or so that using a rounded off number is not going to mess you up on the next step. In this case, when you're just finding the last angle of a triangle, you know 3 of them, I actually just bypass that rule and say triangle adds up to 180. So 180 minus the 90 I know, minus the 73.9 that I know, gives me 16.1. That is the measurement of angle B, 16.1 degrees. I'm going to pause this, I'm going to write out the other way and then come back and talk you through real quick. Okay, the other way we could get B, if we wanted to be technical and say never use things you worked out yourself, would be to look at that triangle again, and instead of having the view from A, we'll look at the view from B. And if we're looking from B, lowercase b, 3.6 becomes our opposite. And of course 13 is still my hypotenuse. So I would do sine B is the side that's opposite to B, which is 3.6, the hypotenuse, which is 13. In order to get the B out of the sine, I do that inverse sine with the little negative 1 again. Inverse sine, 3.6 divided by 13. Calculator tells me that's 16.076. If I'm rounding to the nearest tenth, 0.7, that 0 has to push up because the 7 that follows it is 5, larger than 5. Get 16.1 degrees. That's the same answer we got this way. It was a whole lot more work, so this is one case where I'll let you say, go ahead and do it the short way if you like the short way. Only problem is, just be aware that if somehow you made a mistake on A, you're also going to be making a mistake on B. One more solve the triangle problem. In this case, they did give me a picture. I'm going to transfer the data from the picture into my list. I like this list along the side that shows every single part of it. It helps you to keep track of what you already know, what you need to know. If, however, you're not going to write down every single one, which is not required, you do need to make sure you circle each part as you go. In this problem, I didn't circle as I went because I was putting them in the answer space. If I didn't have it in the answer space, I would have had to circle the A. I would have had to circle the C, which was not given. Well, I'll take that back. We'll assume that one. I would have had to circle the measure of angle A and the measure of angle B. You can see that here I say lowercase a equals 12.5, capital A equals 73.9. Degrees if that's my final answer. Degrees if that's my final answer. But please do not mix up lowercase a and capital A. They mean very different things in this kind of problem. Okay, move to the second problem. I wrote down the angles that were labeled there. That little red square, of course, means 90 degrees. Do you even know whether the 4 is an A, B, or C? If I look here, I know that 4 is directly opposite from capital A, which means that that is lowercase a. The last problem I started with Pythagorean theorem because I knew two sides. This time I don't know two sides. I'm going to start with angles because the angles look easier this time. I know that the angles of a triangle add up to 180 degrees. So I'm going to say start with 180 degrees. Subtract the 90 that I know, subtract the 49 that I know. Use my calculator to figure this one out. 41. And that is the measurement of angle A. I'm going to put degrees on that. If you're not using the answer space on the side, make sure you call that capital A equals 41 degrees. Let's work on those sides. If I'm starting with, let's start with the only angle we know for sure, 41, we figured it out ourselves. We're going to try to avoid working with it. We're going to be working with angle B. Opposite from angle B right here would be the lowercase b, which we need to find. And we're going to call this our opposite because the B is the angle we have to work with. Over here across from the C, we call this our hypotenuse. Of course, it's the longest side. And that leaves this side here, which is touching the angle B, but it is not the hypotenuse. That means this is our adjacent side. Let's see what we know, what we want to know. We want to know B, and B is opposite. And we don't have a number for hypotenuse, we have a number for adjacent. The ratio that uses opposite and adjacent is tangent. So I'm going to start over here with tangent of the B, because it's the only angle I know, is the side that's opposite from B over the side that's adjacent to B. In this case, the opposite was lowercase b. Of course, capital B, opposite would be lowercase b. And the adjacent can't be C, so it must be the A. I don't usually bother to write down that step. Makes more sense to go straight to tangent of the angle I know, 49 degrees, equals the side opposite that, I don't know B, I'll write it down, over the adjacent, which is 4. I need that B by itself. The way that I usually do that is cross multiply. Throw 1 underneath here, cross multiply, so that I end up with 4 times the tangent of 49 equals B. I need the B by itself. B is by itself. I'm ready to put that in my calculator. Depending on your calculator, you might need some pencils around that 49. And what I got out of my calculator is 4.601. Since The directions are asking for the nearest tenth, 4.6, followed by a 0. It's not going to push it up, just 4.6. This is B. If you're not making yourself an answer space on the side, make sure you circle that answer. And I will put it over here and say that B equals 4.6. If they told me inches, feet, meters, miles, I would have to put it there. They didn't tell me. One more to find, part C. Let's see what we can do with C. C is a hypotenuse. I know the adjacent. If I know the adjacent and I know the hypotenuse, I'm going to be using cosine. Cosine B equals the adjacent over the hypotenuse. In this case, the adjacent is A, the hypotenuse is C. Those are the parts I'm going to be working with. So cosine of 49 equals the adjacent side, the side that's touching but isn't a hypotenuse. That's 4. And the hypotenuse, I don't know. That's what I'm trying to find out. Let's deal with that. My preference is put a 1 under here and cross multiply. You could, however, just multiply by C on both sides. You'd still have the right work and the right answers. C times the cosine of 49 equals 4. I need that C by itself. It's not by itself yet. I can't divide out just the 49. Cosine and 49 are all tied together. I need to divide both sides by cosine 49. Cosine 49. This leaves me C equals, let me pause, put that. My calculator told me 6.097. I need it rounded to the nearest tenth. 6.0. But in this case, the number that follows the tenths place is a 9. If it's 5, if it's bigger than 5, that pushes up. Circle that answer, or put it in an answer space over here. Either one's okay. But make sure you have it written down. Those two we had to find ourselves, and angle A we had to find ourselves. Those are the ones that have to be clearly labeled somewhere on that problem. I think that's enough of the solve a triangle problems. If you're still having troubles with solve the triangle, go back and look at the 2 solve the triangle problems that I worked out on 17.1a. I also posted on Schooloop a bunch of videos by other teachers that I don't even know. Okay, remember, having troubles, you can call me, you can email me. I'm willing to work out another problem for the whole class, or I'm willing to just talk to you on the phone and talk you through whatever problem you're having troubles with at the moment. Don't hesitate to call me or email me.